Chapter 11. Our goal in Chapter 11 is understanding how we take a radical and without using a calculator, how to simplify it in what we call lowest terms or simplest form. And so to do this, what we have to try to do is we're going to break down our perfect squares, or use our perfect squares to break down these numbers in such a way that they're written in perfect simplest form. So let me just kind of examine this. We look at 50. I look at my perfect squares. And I say, okay, here's my perfect squares, and I'll write them over here too. Okay, we've got 1 and 4 and 9 and 16 and 25 and 36 and 49 and 64 and 81 and 100. So there's my first big 10. Here's 50, so there's 50 is right there, right? So let's go. Does 49 go into 50?
Yes.
Evenly?
No.
No. Does 36 go evenly into 50? No. Does 25 go evenly into 50? Yes. So what we're going to do is we're going to break down the 50 into two square roots. The largest perfect square, which was 25, times 2. Because 25 times 2 is 50. All right, so our goal is to break down the 50 into a perfect square times something else left over. Well, what's the square root of 25? 5. And so my answer is written 5 root 2. The 5 comes out of the square root, Luke, and the root 2 stays in. So 5 times the square root of 2. That is called simplified form. All right, so our goal is to be able to do these without a calculator. So let's take a look at the next one. 12. I come up here where 12 is on my number line. Okay, 9 doesn't go in, but 4 does. So 4 and left over is 3. Because you're multiplying, Tara. You're not adding, you're multiplying. So the square root of 4 is 2 times root 3. What's that? Simplified form means what's inside the radical sign, no perfect square goes into it. That's all. That's what simplified form is. Let's look at the 20. 20 falls between 16 and 25 over here. 16 doesn't go into 20. 9 doesn't go into 20. But 4 does. How many times does 4 go into 20? 5. So my answer is 2 root 5. So all I'm looking for here, Drew, is what perfect square goes into it. Now notice on each case, I didn't start at the bottom and work up. I started where the number was and I worked down. And I'll explain why. Very simply, when you have larger numbers, if you start at the top and work down, you could find a number that works, but it's not the biggest number that works. So you always want to find the largest number that works. Josh, question.
I noticed that if you take the square root of like 50, it equals if you take like 5 times the square root of negative 2.
Oh, sure. Decimal-wise, they have to be equal. It's the same question. It's the same number. This is not simplified, but this is. Now, why do we not use a decimal? Because a decimal is an approximation. This is an exact answer. As soon as you punch it in your calculator and you get 7 point something, you're approximating. This is exact. This is the exact simplified answer. All right, so let's move down. 27. What's the largest perfect square that goes into 27? 9. So break it into 9. And what's left over? 3. So what will my answer be written as? 3 radical 3. Or very commonly, you're going to hear that said 3 root 3. All right, 500. Well,
100.
Is 100 the largest?
No, 225.
So let's think. 500. I think 100 is the largest. So let's put 100. 100 times 5. What's the square root of 100? 10 root 5. So in each case, we're looking for the largest perfect square that goes into it. Yeah.
Do we know if we didn't choose the highest one?
Let me show you an example of what that would look like. Let's make up a number that would be the case for. So here's a case where we choose a number that's not necessarily the largest one. For example, the square root of 32. Would you all agree that 8 times 4 equals 32? Is 4 a perfect square? So the square root of 4 is 2. However, is there another perfect square that goes into 8?
No.
Okay, guys, the only perfect squares would be 4. So break the 8 down into 4 and 2. Well, what's the square root of 4 again? 2. So now I have 2 times 2 times root 2. So my true answer is 4 root 2. Now, Grace brought up a point before. She said, what about 16? If we had taken our original problem and done what she suggested and broken that into 16 and 2, what's the square root of 16? Same final answer. However, because she started with the largest perfect square, it's one step. We started with the smaller one, we do the problem once, and then we have to do the problem again.
So the right side always has to be the lowest form. It can't have
Your final product, your final result, what's inside the radical sign, must be a number that cannot be divided by a perfect square. You could have 6, you could have 7, you could have 14, but that number here must be unable to be divided by a perfect square. That's what that means in simplest form. All right, so here's our last one. We already kind of did it. How does 8 break down? What times what? 4 and 2. So 2 root 2 is our answer. Okay, so that's the basic setup of radicals and radical simplification. You have to take out squares. Now, I want to make a second column right below this first column. And here I want to list all the perfect squares with regards to x's. Is x squared a perfect square? Sure it is. And x to the 4th is a perfect square. And x to the 6th is a perfect square. And x to the 8th, and x to the 10th, and x to the 12th. When you take the square root of any of those numbers, what do we do to the exponents? Do you remember? Cut them in half. And you can cut any even number in half. That's why they're all perfect squares. So down here I have some examples of issues we have with variables. And so as we look at these, we're still going to break it into 2 square roots. But it's really 2 problems at once. Think with me first about 24. 4 times what?
6.
Okay, is 4 the largest one?
Yes.
Okay, so 4 and 6. So there's the first step. Now we look at the variables. N to the 8th. That's an even number. So that's a perfect square. So let's put the n to the 8th in the first column, because it's even. The square root of 4 is 2. The square root of n to the 8th. Think with me. What times itself equals n to the 8th?
2.
N to the what times n to the what? What times itself equals n to the 8th? N to the, n to the 4th. You cut your exponent in half. And then your leftover garbage is that root 6. You must drag it along. It's still part of the problem, but you can't do anything with it. John?
You just cut the n in half.
Right, we did. Because, is this true? What's x to the 5th times x to the 5th? X to the 10th. Okay, so the square root of x to the 10th is x to the 5th because it's times itself. So you cut your exponents in half when you're taking square roots. All right, let's look at that next one. A little bit different scenario. Here's my 2 radicals. So you're going to start every problem by writing 2 radicals. All right, middle row, right here. What goes into 75? Someone in that middle row. This column's out, that column's out. Middle row. What goes into 75? Brett? 25. Okay, 25 times what? 3. Okay. Now, x to the 5th. This is really straightforward. What's the largest even number below x to the 5th? X to the 4th. So put x to the 4th right there. How many x's are left over? 1. Do you agree that x times x to the 4th is x to the 5th? All right, so now we take our answer. 5, cut the exponent in half, 2, and leftover stuff, root 3x. John, question? Yes. All right, last one. What's different?
There's a number in front.
Okay, so we just drag it along. Put the 3 out front, make your 2 radicals. All right, far column. Luke and Jalon down to Ryan. Largest perfect square that goes into 32. 16 times what's left over? 2. Is x squared an even number? So that all goes in the first column. Drag down the 3. Put a little dot for times. What's the square root of 16? 4. What's the square root of x squared? X. Root 2. Almost there. Got to combine the 3 and the 4. So 12x root 2. So if it's an even exponent, it's nice. If it's an odd exponent, Ryan, you're going to have that leftover one stuck in there. Can't do anything with it. All right, flip it over. Let's look at the back side. I'm trying to give you... Grace, go ahead.
When it's like x to the second power, you just lose that x.
You cut it in half. Cut your exponents in half. Because remember, on the calculator, what have I talked to you about in exponent? A radical square root is also a power of 1/2. That's why you divide by 2. All right, let's flip it over. As we start these, you're going to want to combine things to make it easier for you. So let's combine the radicals on this first one. Radical 5 times radical 5 is radical 25. And what's the square root of 25? 5. So my answer is just 10. Look at 11. There's a 2 out front, there's a 7 out front. So this is how I would think of this. That's 2 times 7 times root 18 times root 6. I'm grouping the numbers together and I'm grouping the radicals together. So 2 times 7 is 14. There's a couple ways to do this. Let me show you what I think is a little bit of the easier way. What goes into 18? Can you think of what goes into 18? All right, 9 goes into it. All right, so let's take out a 9. All right. Square root of 9 is what? 3. So I have a 14 times 3 times root 12. Is root 12 as simplified as it can get? Is there any other perfect square that goes into root 12? Yeah, 4 does. So let's break that down further. While we're doing that, the 14 times the 3, that's 42. What was your question, Josh?
Why did you try to get the 12?
2 and 6.
You just have to multiply.
Yeah, because they're both inside the radical. Okay? So, we've got 42 times 2 times root 3. So I'm continuing to try to break it down as much as I possibly can and go from there. Now the 42 times the 2 gives me an 84. And there's our final answer. Now, that's one way to do it. I did it that way just for the simple reason of hopefully that allows us to make it simpler. Let me show you a different way to go about it. It's a little bit more detailed, but some people like it because it's shorter. It would go like this. I'd break the 2 and the 7 together and the 18 and the 6 together. That's 14, and 18 times 6 is 128. Okay, so my first step is just to combine all the radicals. My second step is to try to think what goes into 128. Well, 64 does, leaving you a 2. Okay? 64 square rooted is 8, and 14 times 8 is 112. Okay? Did I do that right? Did I multiply right there? 128, 64.
Should be 84.
Where did I make a mistake?
The
It's 108? Thank you. That's why this is a dangerous method sometimes. Okay, so we have 14 times root 108. What goes into 108? 9 and 12. Anything bigger than 9 and 12? How about 36 and 3? Okay. 9 and 12 will take you back to the same thing. The square root of 36 is 6. So 84 root 3. So in the same way, you're going to get the same answer, but the danger is you saw exactly what I was doing. I was trying to do things in my head. I made a mistake in the 18 times 6 and got 128. So the danger there is you do too much in your head without your calculator, and you make a slip up.
We're not allowed to use a calculator now.
Right. So if you're trying just to break things down, it's easy just to break down whatever you can to try to pull stuff out. Take out the small things first and continue to take things out if you can't think of the big numbers that go into it.
So on this page we're trying to get the answer now?
Yeah, you're trying to get down to 84 root 3. You want to break it down to a point, so keep taking out root 4, root 9, numbers that you can do in your head.
Why number 10? Mark a number.
Why did what?
You have numbers for answers.
Well, what's the square root of 25? 5. So there's no radical left over. It just is a perfect square. All right, let's kind of look down here. Combine your numbers. 5 times 15 is 75. What's x times x cubed? How many total x's? X to the 4th, good. Now we break it into a radical and another radical. 25 is good. 3 is left over. And now you look at your variables. Because it's even, is that whole thing a perfect square? Yeah, so that whole thing can go in the front. I think the variable parts is easier than the number part, actually. The square root of 25 is 5. Cut the exponent in half, and you have a root 3 left over. So it's just playing with a lot of numbers here and playing with a lot of variables. I'm trying to show you different scenarios. Here I put another 3 in the front. Just as an example, Tara, of dragging it along until the very end. So multiply the 3. Here we go. Let's see. 3 times 12 is 36. And how many total A's? 7. So, is 36 a perfect square? So the whole thing goes in the front. Largest even number below 7? 6. What's left over at the back? 1A. All right, drag down the 3, square root of 36. Cut the exponent in half. 3, drag down the A. Final answer, 18, A cubed, root A. Probably 11 was our hardest one because the numbers got the largest. Now, a little review. Even exponents, cut them in half. Odd exponents, what do you do with that extra one? Bring it to the back, leave the even exponents out front. All right, so let's flip back to the front. Let's take a look at these guidelines. It's often simplest to write the radical as 2 radicals when simplifying. A perfect square times what's left over. All right? Then rewrite the variable as a perfect square in even exponent times the variable to the first power. Then take the square root of the number and the variable, put them in the front of the radical symbol. So this even exponent is going to be a key idea, especially when you have something that's left over. But when it ends up, you're going to have a perfect square times what's left over. That's going to be your goal in every one of these cases, because that perfect square you can make simpler. Save yourself time, find the largest one first that goes in, and that should also save yourself time. Okay?